Good day all and welcome to our webinar BIM workflow. My name is Marit and I will guide you through the process of exchanging models from Revit to SCIA Engineer and the other way around. Let's first start by checking where you can download the plugin. You can find this plugin both on the CATS website as well as on the website scia.net, where you can check the latest versions of the plugin. The latest version of this plugin, we're going to use it as an example, supports both Revit 25 and 24. And if we check into the versions that are exported by SCIA Engineer, we see that this plugin supports both version 24 and version 22 as well as 22.1. Keep this in mind when you download and install the plugin. Right next to it, you find the release notes where you can find some help documents. In this help document, you will also find what types of elements are exported in both directions. And on the right, you find the link to download the latest plugin. Keep in mind that if you want to install this plugin, that you need to uninstall any previous versions that you had installed. Otherwise, the installation will be unsuccessful. Now let's take a look into the topics for today. We're going to start by discussing if you need to use a direct or file exchange, and I will explain to you what the difference is there. Next up, we will take a look into an example project, and from topic 2 until 5, we will open this model in Revit, export it to SCIA Engineer, and come back from SCIA Engineer to Revit. We will discuss the mapping, export options, and import options live with these examples. Lastly, we will discuss any questions at the end. Let's take a look into our first topic, which is the direct or file exchange. What is the difference here? The biggest difference will be found in which licenses that you need. For the file exchange, you will not need a license to use the plugin and create an exported file. Let's start by making an export from Revit to SCIA. In that case, you use the plugin in Revit to export a Revit model, and when you hit export, a webinar example will be created, which is a .r2s file or a Revit to SCIA file. This file can then later on be imported by another party which do have a SCIA license with the button Open From, which will create a new SCIA project, or with Update From, which will update an existing SCIA project. The other way around, we can do the same. In that case, we start from someone who has an active SCIA Engineer license, and he does make the export to a Revit file. In this case, this will also create a .r2s file, and it will include a .def file as well. These two files can then be forwarded to another user who is using Revit but not necessarily has a SCIA Engineer license, and with a plugin, that user will be able to import it into a Revit. So in this case, to use the plugin itself, no SCIA Engineer license is required. That is different from the direct exchange, which you can use. In the direct exchange, we will immediately open SCIA Engineer during the export. When you open the plugin in Revit and you hit export with the direct exchange, SCIA Engineer will be opened automatically and your project will be loaded. If you don't have an active SCIA Engineer license, you will not be able to perform this export with the direct exchange. The other way around, it works similar. You have a project in SCIA Engineer, you open Revit, maybe even a new project into Revit, and you click on Import, and the plugin will automatically read the file that you have opened in SCIA Engineer. So in this case as well, a license is necessary to do so. Let's now take a look into the example project and into all the import and export options that we can use. Before we open the example project, I would like to show you which type of project to create. Whenever you create a new Revit project, to export or import a SCIA file, we advise you to use the structural template. The structural template will also have an influence on the loaded families into Revit, therefore making the mapping from the families in Revit easier to the cross-sections in SCIA Engineer and the other way around. In this case, an example project was already created with the structural template. Before we take a look into the export options, we will first take a look into the content in our project. On the left of this project, you will find the steel structure containing different family types. For example, the column will be an HEA. For some of the beams, we used IPE profiles. And for the trusses, we used both rectangular hollow sections and L angles. On the left of this structure, you find the concrete part. This concrete part has a few walls, all with a thickness of 300 millimeters. In those walls, you will find some openings, both openings which are rectangular and one opening which has a hexagon shape. These shapes will be exported to SCIA Engineer later on as well. And if we take a look into our 1D members, we created a column. That column has a hexagon shape as well. This is created with a new family type. Then lastly, our beams have a general shape, which is a rectangular cross section with a height of 600 mm and a width of 300 mm. For one of the beams, we even added some reinforcement, and we will be able to export this reinforcement to SCIA Engineer as well. All the members we discussed right now are structural members created with the structure tab, both beams, walls, columns and floors. Except for one specific member, which is a foundations slab. This is created with a specific command on top, but also in this structure tab. We will see later on that for this foundation slab, we have different export options. Now, what I want you to keep in mind as well is that components created in Revit cannot be exported. So all the elements need to be created with the structure tab when you want to export them to SCIA Engineer. Since Revit version 2023, it is possible to export this structural model. We still advise you to create an analytical model in Revit, since that analytical model will be able to connect each member in the nodes. With the structural model, it can still be possible that you will need to connect the members properly in SCIA Engineer afterwards. You can create an analytical model in Revit with the Analyze tab. In this case, this is already created and we can make it visible with the visibility settings. So let's change those to make sure that our analytical model is visible. I will also hide the structural model for now so that we can take a look into the analytical properties. Once the analytical model is visible, you will notice that this consists of analytical members, the 1D members like columns and beams, and analytical panels, our 2D members, walls and floors. Everything will be connected in the analytical nodes. In this analytical model, also some boundary conditions are defined, like the end releases of this vertical truss. In this case, these end releases are set, and we will notice later on that these will be exported as hinges. A nodal support is also created underneath these steel columns. In this case, this is a pinned nodal support. Underneath the walls, some supports are added as well. These are line supports, and these will be fixed. In this analytical model, you can also define some load cases, combinations, and some loads. You can find the load cases and combinations in the Manage tab, and there you see that 3 load cases are created and 1 combination is created with these specific factors. These can be taken into account in SCIA Engineer later on if you'd like. We have added some line loads to the permanent load case, some nodal loads as well, and to the wind load cases we added an area load. So this is just to give you an overview of all the elements you can find in this project. Now we can start making an export. You can find the plugin in the CAD tab on top. There on the right you can find our help documents. In here you can find, for example, which type of elements are supported and which types aren't, both for Revit objects and for SCIA objects. Right next to it you find the mapping tables, and these will be quite important for you. These will link the used families from Revit to the used cross-sections in SCIA Engineer and will do the same for the materials. Now let's take a look into those lists. In those lists you will find your Revit materials on the left, and you will see that on the right a SCIA material is selected. The same can be found for cross-section, parameterized cross-sections and your rebar. You can manually define this list by selecting the last row and making a selection of the Revit material, and then at the end of the list selecting the SCIA material which needs to be linked to this. Now it could be that when you open this list for the first time that this list is empty. That is because this list for me was saved during a previous export. We can see here for our cross sections we can do exactly the same. We see here an L angle was selected and it was linked to a specific cross section in SCIA Engineer. What is quite useful for these mapping tables is that you can export them to an XML file. You do that with the buttons on the top right. This is quite useful since this can reduce the working time on these mapping tables. If you create it once, you can keep reusing it and you can even share it with your colleagues. They will be able to import it with the import button and they can select this XML file. In this case, I will remove all the options from the mapping table so we can start with a clean and empty project. After you perform the export once, you will see that these will be filled again with the options that we selected. Let's select them all and delete them so we can continue with our export options. Keep in mind that whenever you make any changes here, that you need to save it with the button on the top right, otherwise your changes will not be saved. Now to start our export, we open the options on the top left of our screen. In these options you find everything you need to make an export. On the bottom left you find the same table that we opened just now, the mapping tables. In here you can open exactly the same dialog. The only difference here is that you will not be able to export it to an XML file or import it. So if you need to do so, you need to open the mapping table from the ribbon on top instead of via these options. So that's just the only difference here. You see it is empty since we removed everything. What you will see here as well is that there is another button called Family Type Mapping. This family type mapping actually already contains a few families. These are the families that were installed through the Autodesk website. For example, I installed some basic families, the Europe specific ones, some from the Netherlands and so on. You will see for these default families that everything is already mapped to the correct SCIA Engineer profiles. So you see here on the right for a few Europe specific cross sections that there is already an equivalent selected. So those will be recognized correctly. If we scroll down, you see that in this case, for me, a lot of these families are already installed. So normally when I will make my export, we will notice that some of my elements will be recognized automatically and I do not need to interfere with that mapping. Right on top of this button you find the Revit family pad. Now that's for something different. If you have created your own families and you want to link them to the mapping table, you need to fill out the directory to these families. So you select the folder where you have saved those families if you have them. In this case, this will remain empty for me. If we then take a look into the settings on top of our dialog, you can select the code in SCIA Engineer, and right below that you can choose direct or file exchange. As explained, we are going to use the direct exchange today, and SCIA Engineer will be opened immediately on my computer. If you are using Revit and you do not have a license for SCIA Engineer, you will use the file exchange option. Right below this setting, you find the SCIA Engineer version. If you cannot find the right version, you add SCIA Engineer by creating a directory to the installation folder. You see here that if I click on Browse, I can add a directory. And as such, you will link it to the installation folder, as I did here, of the right version. In this case, SCIA Engineer 24. Before making our first export, we are going to take a look into the first export option here on top, which is called the Elements to Export. This option is linked to the analytical or structural model, and here we decide which one we are going to use. Keep in mind that if you want to take boundary conditions into account, that you need to export the analytical model, since that is not a part of the structural element. In this case, I want to change it to the structural model first, and to change this option you need to click on Create New. It is not possible to overwrite a previous export with a different type of element. Therefore, create a new file to change this property. In here, we can choose all analytical if we only want to take the analytical component into account. If you only want to take the structural component into account, you select all structural. Keep in mind that we have a third option as well, which is called with both structural and analytical components. In that case, only the elements who contain both parts will be exported. Right now, let's select all structural so we can check the properties of this export. Later on, we will also discuss the export of an analytical model. You start the export with the button on the left. When you start your export, this dialog will pop up. On the left, you find an overview of the different elements in your project and if they were exported or not. On the right, you can find a log file. This is a text file where if there is anything wrong, you will find it here. You will find the mapping as well there. On the bottom left, you find what is happening right now. And in this case, it is showing us the mapping table. The first table we see is the mapping of our material. On the left, you see the Revit material. On the right, we select the SCIA Engineer material. In this case, I will select the right material for each of these elements, and you will see that the list we see for the SCIA materials, that this is already limited. This is limited based on the naming used in Revit, also based on the material category. When you click on Load All to the right, you will see you get the full list of this category. In this case, we do not need to use Load All, so I'm going to toggle that off for this option. Then lastly, we're going to change it for the other materials as well. We do see that structural foundations have no category attached, so we will need to define this for SCIA Engineer itself. I will choose a concrete material as well. Once this is done, you can hit Save, and we can continue to our cross-section mapping. In here on the left you find the family in Revit, on the right you link it to the right SCIA Engineer cross-section. You will see again that if it's the profile library, that the list that you find here is limited. If you cannot find what you need in this list, you can use the button again, Load All, on the left to make sure that all options can be chosen. You will see if you click on it right now, the full library will open and you can select anything you need. In this case, I can search for L angle and I can select a different type if I'd like. In this case, I'm going to use the limited list from before, so I'll toggle off Load All and select the first option. Then for the column that we created, which was a hexagon, we do know that no equivalent SCIA cross-section exists. Therefore, in this case, we can use the option Export as General Section. This means it will create a general cross-section in SCIA Engineer, which is the same as importing an AutoCAD file to create a cross-section. Then lastly, we have our beams, which are a rectangular cross-section. For these, we do know that SCIA Engineer can create rectangular cross-sections, so we can map it. First of all, we choose the right group. In this case, we're going to use the concrete sections of SCIA Engineer, and then we can map the right parameters. With this menu, you link the Revit parameters used to create this family with the parameters used in SCIA Engineer to create a cross-section. On the top, you select the right shape, and then you can select the height and the width to make sure that everything is assigned properly. Once that is done, you can press OK and we can continue with our export. Now we're done with our cross sections, so here we can hit Save again. Now on the right you will see that this mapping is shown. You will get an overview if anything is exported, and on the left I see now that SCIA Engineer is launched and we see the SCIA startup screen on our screen as well. Now that is loading, we can take a look into our SCIA model. I suggest we start by checking our libraries. We start with the materials and then take a look into our cross-sections. The libraries can be found on top as usual, and there we find our materials. I will filter on the used materials for now, and then we should see our steel material S275 was selected with a few concrete materials as well. So those seem to be chosen correctly and mapped as we had chosen. See, the material type here is correct as well, so let's now take a look into our cross sections. We can find those in our libraries as well, and here we should see that a lot of our cross sections are selected from the profile library, and you can always see that in the type of the cross section. For the cross sections here on top, that seems to be correct, and let's check our general cross section as well, that hexagon from our column. We can see the material is chosen correctly and that the shape of this cross section is correct. When I edit this cross section, you will see that we can still change the shape by clicking on edit a second time and selecting the nodes of this cross section. As said, this is similar to importing a cross section shape with an AutoCAD file. So you can still edit it and take those changes into account. In this case, we're not going to change this cross section. We are only going to take a look into those properties, so we will close it. Then lastly, we have our rectangular cross section, and here we see that the parameters we have chosen are mapped correctly. Apart from that, we can check our model. We see our beams and columns are all exported, as well as the reinforcement in that beam. You can check the properties of that reinforcement. You will see the amount of bars and the diameter. You will also see that the cover that was used in Revit is taken into account in these properties as well. Other than that, we immediately see that our openings are exported as we expected, both the rectangular shapes as well as the hexagon shape. What we can take a further look into is some of our nodes. I see here on the top right, for example, that some of our nodes are not properly connected. In this case, it seems that our plate is a bit further than the analytical member of our walls. This can happen in multiple locations depending on how you created the structural model in Revit. A way to overcome this issue, as said, was by creating an analytical model as we did now and making an export of that analytical model. We are going to do this later on, but first we are going to discuss some of the export options. We will discuss these export options since they can have an influence on some of the properties you see here on screen right now, like the surface support and our openings. So let's go back to our Revit dialog. Now I see here that the export options and the log file is still opened on screen. If you want to save this, because there is an error or you want your colleagues to know what mapping you have used, you can save this log file as an RTF file. Now if you save it somewhere, you will be able to open it as a Word document. And in here you can find everything from the mapping to any errors if there was an error. Now let's close this. We are not going to take a look further into this log file, but this is just to show you that you can save it and use it later on. Now let's take a look into those export options. First of all, apart from the elements to export, we can use only selected elements. Right now this was set to no. You can change it to yes, but keep in mind you need to make the selection in the Revit dialog before opening the options here. Right now we're going to leave this as no. The next option is Revit Foundation Slab As. In here you can choose if the foundation slab that we used in our model needs to be exported as a 2D member or a 2D member with a surface support. In this case, we used slab as grade, which means that the 2D member, the plate, will be created and a surface support is added. Since this option was used during our export, we can check this in SCIA Engineer already. So let's take a look there, and here we see that these surface supports are exported and you can even check the properties of the subsoil. Keep in mind that it is possible that you still need to review these properties afterwards in SCIA Engineer and change them accordingly. So in this case, even though we exported the structural model, for the foundation slab, additional data was created. Next up, we can choose if we want to export layers to SCIA Engineer. This was put on yes, so we actually took them into account, and you can find the different layers that were created with the button Layer Mapping on the bottom left. Here you can find the different categories from Revit. Those cannot be changed, but the names used in SCIA Engineer can be changed. In this case, these layers were already used, so we can check them again in SCIA Engineer. If we go to our libraries and we check the used layers, we should find that those 4 layers were created: beam, column, plate and wall, based on the categories in Revit. If we select our elements, we see that our wall is indeed created in the layer wall, and for one of our columns, we find that it is added correctly to the layer column. If you toggle this off, everything will be added in the default layer of SCIA Engineer, which is layer 1. Next up, we have the property Opening as Panel. This was also toggled on to yes. This means that when we make an export for all our openings, an option will be toggled on, which is called Load Panel. And for all our openings, you find that the option Panel is toggled on, so a load panel is created inside the opening. If you choose No in our Revit options, this panel option will be toggled off in SCIA Engineer. Then next up, you can choose if you would like to export your reinforcement or not. Right now there was reinforcement present in one of our beams and we did export them to SCIA Engineer by toggling this to yes. Then lastly, we have an option which can be quite important, which is internal edges with beams. This is toggled on to yes, so this means that this was already created for our project. And if I toggle on the model data, you will see that those internal edges were created. For those who are not familiar with those internal edges will make sure that beams who are modeled in the same plane as a 2D member will be connected properly. Otherwise, these beams will not be connected over the full length of the element. If you toggle this option to no, it will mean that no internal edges will be created and the user will need to define them manually later on in SCIA Engineer. Now that we discussed all the export options which are related to the structural model, we will close our SCIA Engineer project and we will create a new export for the analytical members. So I toggle on create new so I can change the elements to export. In this case, I'm going to use with both structural and analytical component. This means that only the members who both contain a structural part and an analytical member or panel will be exported. Members who only contain the structural component or only the analytical component, like that small part I modeled here up front, will not be exported. The small part I modeled up front are only some analytical panels and one analytical member, but they don't have a structural component. Now, whenever you toggle on the analytical model, you will see that one export option is extra, and that is export a member as a load panel. And that is actually also related to one of the properties of an analytical member. You will see here that the structural role can be changed from a wall or floor to a panel. If I change this structural role for this member to a panel, I can export this as a load panel to SCIA Engineer. So in this case, this member will not be a 2D wall, but it will be a load panel which can transfer loads to specific elements. I will make sure that this option is toggled on to yes to make sure that we can check what happens when we use this option. Then, whenever you change it to the analytical model, you will also see that some options on the bottom change. Right below our export options, you can find all the options we can choose to ignore. Before, we didn't have the option to ignore the loads. Right now, we can choose to ignore them. In this case, I would like to export everything, so I will make sure that none of these components are ignored. So let's set them all to no. Now that everything is set up, we can make the same export. The options that we have during the export itself for mapping and so on are quite similar to that of the structural model. So in this case we have the same list, but you see the loads are listed here already. On the right we have the same log file. I see here I need to map the cross section of my column again, so I will hit save. My material and so on is the same, so that is already mapped. What I can see now on the right is that there is indeed a warning in red about an analytical line which may be not in the right position. You can always check this later on in SCIA Engineer. This does not mean that my floor is not exported. In this case it says it is exported, but we need to verify the location. Now that the export is done, we can open SCIA Engineer and see what is exported there. I suggest that we start by taking a look into the boundary conditions of all our members. Let's first take a look into those internal edges. That was toggled on to yes, so also for the analytical model which is exported, these internal edges are created. Then let's check the member releases, so the hinges on that vertical truss we discussed earlier today. If you remember it correctly, we had a hinge on the bottom and the top. On the bottom, all the rotations were set to 3. On the top, only the rotation around the Y and Z axis were set to 3. And that is taken into account here correctly. On the bottom and on the top, a different hinge is added. Then if we check our nodal support, we see in this case underneath our column, we indeed find a hinged support. For our concrete column, we added a fixed support in Revit. So this is also taken into account in SCIA Engineer. For our walls, we added a line support, and that was a hinged line support. So as you see here, it is indeed a fixed line support. Now if we then take a look into that wall that we exported as a panel, then you see that in this case it is indeed exported as a load panel and that you can change the properties in SCIA Engineer. Right now the first default parameters are used, so you will need to modify these properties manually. In this case we can change a few of them, but we will not be able to use this load panel since the location of the load panel in our project does not make any sense. But it was just to show you as an example that you can make an export of an element as a load panel. Then lastly, we can check our load cases. If we check the permanent loads, we can find our line loads and the nodal loads that we defined with the same value as in Revit. And if we check the wind load, we will see that we find the area load that we defined in Revit. Other than that, I can note that we created a load case SW in Revit, but that is not taken into account as the self-weight. The self-weight will be automatically created during the export. You can choose what to do with this yourself. In this case, I will remove the self-weight load case and I will make sure the SW from Revit is taken into account as the self-weight. But those are some manual modifications if you have created some combinations and so on in Revit as well. If we check those combinations right now, we will see that only one combination is created, and this is using the exact same factors as we defined earlier in Revit itself. Whether or not you define these boundary conditions in Revit before exporting is up to you. I believe in most cases Revit is used for the model and the boundary conditions are added later on in SCIA Engineer. Up until now, we only created new exports. Now I would like to discuss with you what would happen if we update a project. So instead of creating a new export, we're going to make some changes and update our SCIA Engineer project. In this case, I will start by making some changes in Revit and updating SCIA Engineer. We will also check the other way around later on, from SCIA to Revit. Now in this case, I will first make sure that my structural model is visible again, so that we can make some changes to both the structural and the analytical model. In this case, I'm going to do this manually. Keep in mind that if you make some changes, you can also choose to regenerate the analytical model with the same properties as before. First of all, let's make some changes to some elements. I am going to remove these L angles on the left of our structures. Those are two members and we will be able to check later on if they will be removed in SCIA Engineer. Next up, let's remove an opening as well. I'm going to remove the opening both in the structural and the analytical member. Then next up, let's change the geometry. I am going to choose this wall and change the length of it. As said, I'm going to need to modify this for both the structural member by changing the geometry as I do now, but I will also make sure that the analytical panel is modified as well. In this case, I'm going to do this manually since it is quite quick, and I will make sure that the member of my beam will be moved back. So those are a few changes to the geometry. What can we change as well? Let's change one of our boundary conditions from hinged to fixed. And then let's change the member releases of this specific member we were discussing earlier. I'm going to keep the member releases, but I am going to change them to user defined. That way I can make sure only the rotation around the z-axis is set to free, all the rest will be set to rigid. Make sure we apply these changes, and then we can take a look into changing the cross-section of one of our members. Let's change the cross-section of one of our beams. I'm going to make sure that this one is changed, and let's change it to a totally different one, a steel cross-section, HEA, for example. I'll make sure that I change this for both the structural component again and the analytical member, since otherwise we need to regenerate this. And after I change this, I will also check the selected material for both properties to make sure it's the same material as our different members. But of course it could be different than the other ones. It's not necessary to change this if you want to use a different material. Now that those changes are made, we can check what happens when we update our project. So I go back to my CAD tab and I will open the options again. I will not change any of these options here. I see the reinforcement is ignored, but we're going to use that and we're going to make this export again. This will look the same. You will see on the right in the log file that it's not creating a new one, but it's updating SCIA Engineer. It will show me the exact same mapping when necessary, and it will make the changes where it's due. Once that SCIA Engineer is launched, we will be able to take a look into the changed properties. Let's take a look. We see first of all that our load panel still exists, so that is not modified and those properties are still the same. Our wall here is made longer and we see that the openings are removed in the back wall. Let's take a look into our boundary conditions for this member. Now we see that both hinges still exist, but the properties are changed and now only rotation around the z-axis is allowed. I do see my support here is still hinged, so I assume I mistakenly not saved my changes. Let's check that. And in here I see indeed my boundary condition was still hinged in Revit. So that was something I mistakenly missed before. If I update my model again, we should see that these changes are also taken into account correctly. So let's take a look there. This is exactly the same. It will still prompt me the mapping when necessary and so on. And we will immediately check if our support is modified as well. I see our export is done, so let's take a look. And now I see indeed this boundary condition is fixed again. Lastly, we changed our cross-section of the beam on the right, and you see that right now that cross-section is an HEA and the material is steel. So those changes are correctly taken into account. In the properties of this beam, you can find a property that we haven't discussed before, which is the eccentricity of the member system line. You will see for this beam, this is listed to the top. This is also a property that is actually defined in the structural model of Revit. You will see based on the volumes that this is correctly taken into account and that other beams have the same setting too. If we take a look into the structural model in Revit, we will see that there is a property called justification Z, and that for this property the top is selected as well. Keep in mind that this eccentricity has an influence in SCIA Engineer and on the analysis results. Now we've seen what happens when we change something in the original Revit model and update the SCIA Engineer project. But what is relevant as well is what happens when we change something in SCIA Engineer and want to update the Revit model accordingly. So in this case, let's make a few changes here and update our Revit model. I will start by adding some members. For example, in this case, it could be that we notice that our structure is not sufficient and that an extra column is necessary. So let's add one of those. Other than that, the engineer might decide that that hexagon column cannot be created in this case and that we need to use a different shape. So let's change that cross-section. Right now this is indeed our general cross-section and I'll change it to a new one that we create in SCIA Engineer, for example a circular one. So let's select our circle shape, let's make it a bit bigger and let's change the cross-section of this column. There we are, check the geometry with the volumes and we see that this is correctly changed. Now lastly, we saw before that we could export reinforcement from Revit to SCIA and we can do the same the other way around. We can add some reinforcement in SCIA Engineer and export it back to Revit later on. So let's add some reinforcement to this beam specifically. Let's select it. In this case, I'm just going to use some user reinforcement, but if you use reinforcement created with the provided reinforcement template, that will also be supported. There we are. I'm just going to use a basic template with 4 longitudinal bars and a few stirrups, and we're not going to edit any of those properties any further. We're going to do the same for our 2D reinforcement. We can add some in the wall at the back. There we are. All these changes should be taken into account when importing this back into Revit. Now, whenever you import your SCIA model into Revit again, we do have some other options to take into account. The analysis results will be discussed later on since we need a calculated project for that, but we can check the other options. There are a few options here to ignore some generated loads or the created reinforcements, and we can check how levels need to be created in Revit. In this case, I'm going to use the Revit levels since this was originally created in Revit. Other than that, we can choose if we want our reinforcement geometry to be edited when updating, and we can choose if our openings in 2D members need to be updated or if our member size itself need to be updated. Now let's start our import. This will run in exactly the same way. It will start up as you expect. On the left you see everything that is taken into account and the mapping for our circle column pops up. We can see if we need to map this element, but we get a warning that these parameters are automatically taken into account. Keep in mind that during this export, member releases like the hinges and other boundary conditions can be taken into account during the import. If that is not necessary, choose to ignore them from the beginning, since that can reduce the import time. If you want to take them into account, of course, you will see in here that it tries to import those members and change the geometry of other members as well. I got a warning before which called out a Revit limitation that has to do with some of the beams I created in Revit. Those were a part of a beam system and it is not possible to modify them separately. Therefore, for each of those beams, I got a warning that this was not possible to edit. We did not make any modifications to those in SCIA Engineer, so that should not result in an issue. Lastly, I get another warning about some Revit limitations, about some eccentricities that cannot be taken into account. That is just a warning, because if I check the line right below, I see the column should have been added. We can always check the properties afterwards, and as said, you can save this log file if necessary. If we go a bit upwards, we also see that our reinforcement was created correctly, so let's take a look into our Revit model again. Let's close all our parameters. We see immediately that our column was created. That is now an IPE 200 and it has both a structural and analytical component. For our column made out of concrete, we see that a circular column is found right now, so that is mapped correctly and taken into account. We will also see that our reinforcement is added right now. In this beam we created some reinforcement with diameter 16 and we can check all the properties as well. Then in our wall we created a small patch of reinforcement, and if we check that one we will see that the right diameters are used, but we need to make sure that we select the rebar and not only the structural reinforcement bars. So let's make a full selection and then we can check the structural rebar itself. If we scroll a bit down you will see the quantity. On the top you will see that diameter 6 is used as we applied in SCIA Engineer. So all these properties can be updated from your SCIA file back into Revit afterwards, and that makes it quite a useful tool. Now lastly, I would also like to discuss what happens when we try to import some analysis results. And that I'm going to do with a new and a bit smaller project which is already created. This new project contains a few steel cross-sections, a few concrete cross-sections and some 2D members as well. We calculated only for the self-weight to import it right now. I see some supports are defined as well, some hinges are found on these concrete beams and so on. Let's calculate this project before we open a new project into Revit. And there we are. So this can be closed. We go back to Revit. I will close this model as well and create a new one. Whenever you create a new one, as said, choose the structural template. It will make sure the mapping goes correctly. Importing this works exactly the same. We go to the cut step on top and we check the different options that we have there. Options of course remain the same. We discussed them before. You can scroll down if you want to take a look into the import options. You can choose what you like to ignore and what you don't want to ignore, and in this case we are not going to ignore anything of the supports and so on. Let's take a look into our import options again. We're going to choose how our levels need to be created, and we can choose to create the levels based on the slabs in SCIA Engineer. In this case we can ignore the reinforcements since that is no longer there, and now we would like to take the analysis results into account. So let's change that to yes. Lastly, we can now change the type of elements to create during the import. This option was not there before since we were already importing or updating an existing Revit model. I am going to choose to create both the structural and analytical component in Revit for now. That can make it also easier to export it back to SCIA Engineer later on. Now when you import this model, we first need to save the Revit model itself, since it's not saved yet, so let's choose a location to save this one. I will call it right now Import SCIA. The import will go through the same stages. We see immediately that the analysis results are already imported and that now all the other items will be imported as well. So we see the load cases, combinations, the mapping will be prompted again, but it's a rectangular cross-section so that it's mapped automatically, and then all our members are imported. In this case as well, I see there is a warning about the orientation of the columns, so it could be something that needs to be verified. All our boundary conditions are added as well, and then we can check the model. In this case, I am going to focus on the results that are imported. But as you can see, everything is imported as expected, and we can make the structural model visible again to see the structural components. In this case, everything seems to be fine, and the orientation of the columns seems to be correct and as expected as well. Now, if you want to take a look into those imported results, you can go to the Analyze tab. In this tab at the end, you can find the Result Explorer, and in here you can select which results you would like to see. In this case we can make a selection, but I'm going to select the load case self-weight, which is load case 1. That's the same as what you define in SCIA Engineer, so for me that's the self-weight that we take into account, and then we choose what results we would like to take a look into. If we apply this, those results will be visible on view, and you can do the same for reaction forces as well as bending moments and so on. So let's take a look into the internal forces, bending moment MY, refresh those results, and we should find exactly what we found in SCIA Engineer. So that can be quite useful as well.